All right. So I did not. Would you like me to go back? I will gladly go over number 2. Here is number 2. We've done this one quite a bit the last couple days, and I know you were in the session yesterday. But if you want to look at number 2, here's what it looked like. We had this set up right here. We were trying to determine when this function was differentiable. So if we're determining when that's differentiable, we want to know when it's continuous. And so this part over here is going to tell me continuous. It's going to be continuous when the limit from the left and the limit from the right are equal to each other. It's also going to include the value because it's underlined. So we took ax plus 5 and bx squared. We set them equal to each other, and then we went ahead and plugged in 1. So when I plugged in 1 here, it just became a plus 5. Plugged in 1 there, it got me b. So there was one equation, but I couldn't really do anything with that equation yet because I had 2 variables and 1 equation. So then we also wanted to make sure it was differentiable. In order to be differentiable, the derivatives need to be approaching the same value as well. So to find that, we did the limit as x approaches 1 from the left of the derivative. So I had to take the derivative of ax plus 5. A is a constant. So if I asked you what was the derivative of 2x, the derivative of 2x would be 2. So the derivative of ax would just be a. The derivative of 5 goes away. And then we're taking the limit on the right side, so bx squared. If I said what was the derivative of 3x squared, you would say it is 2 times 3x. So it is 2 times bx when I take that derivative. We set them equal to each other. We're finding the limit as x approaches 1, so I plugged in 1 here for x. I got 2b is equal to a. Then I did some good old elimination substitution. I took this guy, plugged it in for b, distributed it out, solved for a. A was negative 10, plugged back in right there to find my b, and my b was negative 5. Kind of makes sense? Anyone lost there that needs a different explanation? That definitely could be a question that they ask on a multiple choice portion of it. It's just one of those things that you got to get used to a little bit. All right. Nobody's really responding in the chat, so we'll keep going then. All right. Trig derivatives, that's where we're headed today. So trig derivatives, these are the ones we need to memorize. So these are pretty much just straight memorization. We will add a little bit more layer to it when we get back from break, but right now it is just memorization. So as I look at this first one, okay, really, really important one. If you have your notes out, throw like 5 stars by it because it's one you got to have memorized. You need to know that the derivative of sine is cosine, okay? And that might be a weird thing, but we did this in Desmos the other day as well. But think about this, all right? If I were to graph the derivative, if I were to graph f prime, okay, this is a graph of sine. The slope right there would be 0. The slope right there would be 0. The slope right there would be 0. This slope right here would be 1. This slope right here would be negative 1. And if I connected these dots like so, you would see that the derivative of sine gets you this purple line. And that purple line here for us, that is a cosine graph. So it's really strange that they match up that way, but they do. And so you need to know that the derivative of sine is cosine. And if we looked at a cosine graph and we took the derivative of cosine, another super important one, 5 stars, the derivative of cosine is negative sine. The derivative is cosine is negative sine. If you don't believe me, graph it out and kind of work with it there. But 2 very important things, we're going to use them every single day from here on out. Our next one here, the derivative of tangent is secant squared. Okay, the derivative of tangent is secant squared. That's an important one. Okay, I'm gonna give it 3 stars. Okay, very important question. These 2, all of the time, we're going to use them. This one we're going to use pretty often. Okay, make sure you know that one. Tangent is secant squared. You need to memorize that. Notice here that square sign is there. That is the same thing as secant x all squared. They just like to take that square and put it right there. Don't let that scare you. Derivative of the next most important one up here is secant. Because we get this one, the derivative of tangent is secant squared, the derivative of secant is secant tangent. That is one you need to memorize. Okay, the derivative of secant is secant tangent. That one on a scale of 1 to 5, that's probably one, we'll call it 2 stars. That one's a 2-star problem. That one's a 3-star. That one's a 2-star. And then we got these last two. The derivative of cosecant is negative cosecant cotangent. Notice that it's pretty similar to this one. It's pretty similar, secant, cosecant. We always know that those kind of go together. Instead of secant tangent, it's cosecant cotangent, and it's a negative sign. Okay, same thing over here. We got cotangent. We're taking the derivative of cotangent. Oh, that's like tangent. The derivative of cotangent is negative cosecant squared. If we were to do the same star rating, this guy would be like a half a star. I don't know how the best way to draw a half a star is, but a half a star. Important, but not crazy important. Same thing here. I'm going to give it a 1 star. It is the least important of the group. Okay, if you are going into Calc BC, you will use those 1 stars a little bit. If you're going into Calc AB, we don't use the 1 stars at all. Those are not things that they make you memorize for the AP exam. So kind of know where you're at. The first two, super important. Tangent, you definitely need to know it. Okay, a quick reminder here to help you out. Any one that starts with a C. So cosine, it's negative sign. Cosecant, it's negative. Cotangent, it's negative. If it starts with a C, it is negative. And remember that tangent and cotangent have very similar derivatives. Cosecant and secant have very similar derivatives. Just be able to keep them separate. Questions there? That was a whole lot of me talking and you not responding, so I know that's as boring as can be. Let's look at number 1. Number 1 says f of x is equal to x cubed times sine of x. Find f prime of x. Tell me in the chat, what special calculus rule are you going to need here to take the derivative? Good, Marley, Abby, Karis, Will, good. Interesting way to spell that, but yes, I agree. Good, we are going to need product rule here. We've got f, we are trying to find f prime of x. So it's going to be first derivative of the second plus second derivative of the first. Go ahead, it's okay. Go ahead and try to type that in. So we use product rule here. Go ahead, try to find that derivative, type it into the chat so I can see what you're doing here. Good, starting to get some good answers. Let's write this thing out. So it's first x cubed times the derivative of sine. Good, derivative of sine is cosine x plus second sine x times the derivative of the first. The derivative of the first is 3x squared. Boom, there is my answer. Didn't really have to do a whole lot. Not a whole lot we could simplify there. That's example 1. All right, let's look at example 2. So example 2 says find dy dx if y equals cosine of x all over 1 minus sine x. Tell me in the chat, what special rule are we using here? We are taking two things and we are dividing them. So of course, we are using quotient rule here, quotient rule. Let's look at that. So quotient rule, we are doing low d high minus high d low all over low low. So let's just do it together here. I really don't need to see you type this into the chat because this could be pretty rough. But we're doing low, 1 minus sine x, d high. Think about it. Type this into the chat. What is the derivative of the top going to look like? Derivative of the top. Good. We've got cosine. The derivative of cosine is negative sine x. And be careful there because sometimes it might look like minus sine x. You are multiplying it as negative sine x. So just be aware of that as you write that in. Minus high d low, high cosine. D low, the derivative of the bottom. Well, the derivative of 1 would go away. What about the derivative of negative sine? Tell me in the chat, what do you think the derivative of negative sine is going to be? Good. The negative sign is a constant. It's like just a -1. So if we didn't have that negative sign, oh, what's the derivative of sine? Oh, it's cosine. And then we've got that -1 already there. So it's going to be -1 times cosine, or just negative cosine on top, all over, low. So 1 minus sine squared. That would be a perfectly good answer. We could go ahead and simplify that. I am not going to do that because I don't think that's something that you would particularly want me to do. But like things like, hey, this would become positive cosine squared. Yeah, I'm going to go super fast, I guess. Positive cosine squared. And if I FOILed this out, it would be -1, or negative sine x plus sine squared, all over 1 minus sine of x. I'm sorry, sine squared. That. And then this looks kind of strange, but what could I do from here? Okay, think about this for a second. Use your brain. What could I do from here to simplify? Anybody want to jump on the mic and tell me what do you think we could do at this point to simplify this guy?
So basically, because of our trig identities, sine squared of x plus cosine squared of x, would that be 1?
That is 1. So we've got 1. Good. And then what else from there?
And then on the bottom, you have 1 minus sine of x on top, and then that squared on bottom, so you could cancel one of those out.
Awesome.
So it's 1 over 1 minus sine x.
Wonderful. Thank you. Good job, Marley. So she said, hey, this sine squared plus cosine squared is 1, and then it's 1 minus sine x on top. And then since we have 1 minus sine x on bottom, she's going to really simplify that into 1 over 1 minus sine x. That is not something we do a lot, at least in Calc AB we don't. I might have to work with Mrs. Mendenhall more to figure out what else we could do there. But that is something that we can do pretty easily. That sine squared plus cosine squared equals 1. That is one you probably want to look at. But other than that, it's not too bad. All right, let's keep going here. Number 3 says, find the equations that are tangent and normal to y equals tangent x at x is equal to pi over 3. Tangent and normal. So what that means is, when I look at this problem, we're going to have two different answers: y minus, x minus, y minus, x minus. We're writing tangent lines, equations. This is going to be my tangent line. This is going to be my normal line. Pi over 3, so I can put pi over 3, pi over 3. We are doing this equation, tangent x. So tell me in the chat what number for both equations is going to go right there. Yep, we're just finding the y value, so it'd be y equals tangent of pi over 3, and we just think, all right, pi over 3 is not that one, it's that one. If you hold up your finger and put that one down, this would be 1/2 radical 3 over 2. So it's y over x. It is root 3. Sorry, I'm texting with Mrs. Mendenhall at the same time. We got radical 3 there for that one. Then we want to know slope. So if we want to know slope here, we need to take this derivative. We've got y equals tangent x, so y prime, the derivative is going to be equal to what? What is the derivative of tangent going to get me? Derivative of tangent is secant squared. So think about that. You're plugging in, and we want to find the slope. So for this one right here, for the tangent line, you are plugging pi over 3 in right there. Tell me what that is going to look like. what is that going to look like right there? We're doing secant at pi over 3. Here is pi over 3 right here. I'm doing secant. That goes with cosine, so it's 1/2. I'm taking 1/2, and I am going to do, what are you looking for, Hannah? Oh, hang on one second. I'm problem solving for my wife. It's because I don't know. Sorry, my wife is trying to do her own Zoom meeting at the same time. It should get you 1/2, and then we are taking 1/2 and we are squaring it, so the answer should have been 4 there. It's a different. I don't know where the other Chromebook is. The iPad's plugged in on the side table, though, if all else fails. So this tangent line would be 4. So if this is 4, what am I putting right here for the normal line? If derivative is 4, then this would be -1/4. Good, Abby, because that is the derivative. The derivative is 4, so we're doing perpendicular. Perpendicular is -1/4. Horizontal tangents. Let's do this one real quick. Horizontal tangent. Show me with your arm. What does horizontal tangent mean? Or type into the chat. What does horizontal tangent mean for us here? Horizontal tangent means. Good. Abby gave me the graph as well. It means, good Sam, good Marley. It means the derivative is 0, or more specifically here, y prime in this case is going to be 0. So if I take the derivative of x, that would get me 1 plus 2 cosine x. Tell me in the chat, what do you think the derivative of 2 cosine x is going to be? Yep. 2 cosine x becomes -2 sine x. 1 minus 2 sine x. That's my derivative. I want to know when there's going to be a horizontal tangent. So as a lot of you just stated, that means I want to know when this thing is equal to 0. Okay, we want to know when it's equal to 0. So we're going to solve that. I'm going to do it quickly. Excuse me, because that's not the most important part of this. We're going to divide by -1, or subtract -1, divide by -2. When is sine of x going to be equal to 1/2? Sine of x is equal to 1/2 at pi over 6 and 5 pi over 6. Those are the two places on this graph when sine is going to be 1/2. Those two spots right there. Questions there? Let's keep it going. We really only got 2 problems left. 3 problems left. See what you can do with it. Number 5. So number 5, they asked on the AP exam last year. So it's kind of a strange question, but this is what they did. And we're going to look at that right now. So number 5 says, find f with the little 37. So that means the 37th derivative. Okay, the 37th derivative. This could be a little bit weird, but let's start going here. Let's find f prime. Derivative of cosine, as I've made you state quite a few times already, the derivative of cosine is negative sine. And cool, let's find the second derivative. The second derivative, negative sine, would become negative cosine. We did that one earlier, but remember, sine just becomes cosine. We don't change the sign when we take derivative of sine. F triple prime, the third derivative. What would the derivative of negative cosine be in the chat? What do you think the derivative of negative cosine would be? Good Marley, good Andrew, good Abby, good Sam, good Elena, Anna, good, Kara's good. The derivative of negative cosine, because it starts with a C, it's going to change my sign. So now it's going to go back to positive sine x. Keep going here. Think for a second. What do you think the 37th derivative would be? Okay, 37th derivative would be. Think about what you think it would be here. Goodwill. Good, Marley. Good, Sam. Good, Karis. Good, Elena. Good, Jacob. Good, Abby. So the third derivative is sine. The fourth derivative, would be cosine. Notice that this is the same thing as the original one. And so you could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and keep going like that. Or you could know your multiples. The fourth, this would be the fourth derivative, and the 8th, and the 12th, and the 16th, and the 20th, 24, 28, 32, 36. And so the 37th derivative would go back to that guy right there, which is negative sine x. So the 37th derivative is negative sine x. And that leads me to one of my favorite things, the circle of trig. Here's what the circle of trig states. We've got sine of x. It's kind of our starting point. The derivative of sine x, as we know, is cosine x. If I took the derivative of cosine x, that would get me negative sine x. If I took the derivative of negative sine x, the derivative of negative sine x would be negative cosine x, and the derivative of that guy would get me back to sine. That is the circle of trig. Sine, cosine, negative cosine, and then it repeats. I had this student in class a long time ago that was trying to memorize this, and so he looked at this and saw the first part of each one, and he said, oh, this right here, SC and then negative S, negative C is Snapchat and then negative Snapchat, where Snapchat is good for a while and then Snapchat is bad for a while, and then it's good for a while, then bad for a while. SC, negative S, negative C. It is totally dumb, but it helps me to remember it as well. Hopefully it does for you as well. Snapchat, negative Snapchat. That is how we are going to memorize our derivatives. All right, let's keep going. We're going to not do number 7, so we're not going to worry about that. Let's do these last two, number 6, A and B. Okay, Snapchat, negative Snapchat for those. Let's look at this one. 4x squared minus cotangent x. We're just taking the derivative, y prime. That's 8x. Without flipping your paper over, try to remember, what is the derivative of cotangent going to be? Derivative of cotangent. Is the sign going to change? If I'm taking the derivative of cotangent, is the sign going to change? I thought these examples should be on there. If not, we're good. Oh, no, notes are different. I don't know what notes you have. How much different are your notes? These are the ones that I got. Sorry, you might have a little. Are all of these ones different or just these two? I don't know what notes you guys have. Let me check. See if I've got the notes you're doing. Oh, I'm pulling them up. You might have my pre-calc notes, to be honest, or my calculus notes. Everything up until example 5 is the same. I don't know. I don't know where you're getting them from. Let me pull up the website. Anybody want to tell me what the problem you're doing is currently? I'm trying to find it real quick. Yeah, I know you got much one. I'm going to Schwann Academy right now, so I can see them too. I don't know how I would have different notes on Schwann Academy than what I'm looking at because I uploaded them. Oh, okay. So, okay. You guys have my pre-calc notes or my regular calculus notes, not my pre-calc notes. That's fine. All right, let's call it a day here anyways. It's fine. If you don't have them written down, it's not a big deal. All we were going to do is practice some problems here. So what I'm going to do is just pull up Quizlet because we've really done everything we need to do for the day. Okay, we've gone through it. We understand what's going on for the most part. Yeah, I see it now. We could take derivatives of that. That was just practice, to be honest. Those were just some practice examples that I had for my calc kids, and then realized that I never asked them to find the derivatives of sine and cosine and things like that. And so that's why I adjusted. So on your screen, I just changed semester. There we go. I'm going to hold up a flashcard, and in the chat, you are going to tell me what the derivative is, because that is the most important part of what we're doing today. So, yeah, it says it. We did the same thing. The only difference between AP Calc and what we were doing there was in AP Calc, they do not have to worry about secant and cosecant, or cosecant and cotangent, so I didn't even have them on there. So that is why it looks a little bit different. Answer with the definition. All right, so on your screen, you have a card. In the chat, you're going to tell me what the derivative of secant x is. So we're just going to memorize these, see what we do. Derivative of secant, not going to change signs because it doesn't start with C. The derivative of secant is secant tangent. Marley, Will, Abby, you're the fastest typers. Everybody else is getting it as well. Let's look at the next one. Ready? Well, let's look at, secant tangent. Very exciting. Next one, tangent. What is the derivative of tangent? We're looking for the fastest typers without being cheaters. Don't be a cheater. Sam was our fastest typer. Karis was Sam. And then Elena and Abby. Good. The derivative of tangent is secant squared. No negative because it doesn't start with a C. Next one. Start over. Derivative of cotangent. What is the derivative of cotangent? Derivative of cotangent is, I got two, Abby, Karis, and Marley was our third one. Negative cosecant squared because it starts with a C. Cotangents, like tangent. Tangent, the derivative of tangent is secant. The derivative of cotangent is cosecant. Oh, but it starts with a C, so it's negative. Don't forget to square it. Next one. Derivative of cosecant. What is the derivative of cosecant? I don't know. They're very fast, Anna. It's scary sometimes. Abby is our fastest. And then Karis. Oh, but Karis was typing quick. Elena, yep, good stuff. Marley Weller up there as well. The derivative of cosecant. Is it going to change signs? Yeah, it's going to change signs. It starts with a C. So negative cosecant, cotangent, cosecant, cosecant, cotangent. Notice that it has x in it twice. Negative cosecant x, cotangent x. Next one. Derivative of cosine. What's the derivative of cosine going to be? Oh my, Marley was ready. Marley, Karis, Abby, you guys are fast typers. I like it. Negative sine. It starts with a C, so it goes negative, and cosine goes with sine. Next one. Derivative of sine. Sam was quick. You guys, Marley, Abby, Karis, Will, Elena, Jacob, Anna. Good. The derivative of sine is cosine. Starts with a C. Tangent. Sam, Karis, Elena, Abby, Will, Andrew, good stuff. Andrew, you're definitely at a disadvantage being on your phone. They're going a little bit quicker without it. Good. And I think, Anna, you were on your phone yesterday, so that might be your biggest issue. Keyboards are nice for this game. Sam, Karis, and Elena were our top three. Good stuff. We got two more, I think, and we're starting to do some repeating, and that's fine. Negative cosine. What is the derivative of negative cosine? Oh, okay. Sine. I forgot to read out who had them fast. I think some people are just starting to guess which one we're doing. Sam was our winner, followed by Karis and Will as our top three. Marley, Elena, and Jacob, and Abby, and Andrew are all correct as well. Last one, derivative of secant. Elena was our first one, and then Marley, and then Abby, and then Will, and Sam and Karis. The derivative of secant is secant tangent. There we go. So more than anything else today, we were just memorizing some derivatives. If you could get through that last part, great. We did a couple other types of examples in there as well, but that's what we needed to get to. So if you understood what was going on there, you're going to be fine. We had some other examples in our notes. You could go through those and not really have any issues with that. I'm looking at what's given there compared to what's on Schwann Academy. Same thing. Okay. We are going on a 3-week hiatus. All right. So for the next 3 weeks, I'm not going to give you anything until after the week we get back from spring break. My plan might be to start uploading stuff sooner rather than later, but nothing is due. And so I'm going to try to give you stuff a little bit early That way, if you're bored at home like me, you can start going with it. We got to keep learning stuff. I know that's weird, and I would much rather be in the classroom, but this is going to be, unfortunately, our new reality for a little bit. Okay, I'd love to get back in May, but I don't even know if that's going to happen at this point. So we're going to just try to play it by ear. My goal is to get you as prepared as prepared as possible for Calc BC, and try to make sure that you're ready for Mrs. Mendenhall. That way, next year you'll be up to date, and I will be your support all summer long. If for some reason we weren't to go back, all summer long, I will help you guys learn whatever you need to learn, and you can ask me questions and text me and do all those things. I will gladly do whatever you need. All right. So I think I'm going to cut it here today. If you've got questions or anything you want to share in the chat, please do. I'll hang out here for another 5 minutes or so. But otherwise, have a good spring break. If you miss me, you can go back and watch some videos and learn what you're missing. I miss class as well. Have a good day, guys, and we'll see you soon. Bye, Karis. Have a good break. You too, Jacob. No problem, man. I know it's crazy. It's a struggle for sure, but